understand on how intense this particular training was. We will cover a lot of additional stuff, a lot of additional code in the subsequent sessions. This is the first time that we are trying to map the training curriculum to BTech in data science. Of course, beyond this, there are many other things. We will slowly and steadily be including a lot of additional activities, additional code, for everyone's practice. So just to do a quick recap once again, we started off by talking about history, about features, variables, types of operators, variables in Python, data types in Python, conditional statements, which includes if else, if statements, nested if statements, then loops, wherein we have finite loops, infinite loops, break, pass, etc. We also spent some time on the functions. We have built-in functions, custom-defined functions. We have types of arguments. Okay, and then we have looked at exceptional handling. And then we have also started looking at libraries. And that is exactly what we are doing now. So if I just were to go here, we are now supposed to talk about NumPy. Yesterday or in the previous session, we have covered until string operations, right? And majorly we have used regular expressions and we could do a lot of operations. And here we have Python packages for data analysis, and we are talking about NumPy. This is how you import any library. We are importing NumPy, okay? And then each time you want to call any functions which are part of NumPy library, we might have to type NumPy dot the name of the function. Instead, if you load this as an abbreviated format as NP, then you can use NP dot array of numbers. So here we are creating a list of elements in variable X. You're creating a variable or an object called X, and we are adding all these numbers 10, 21, 3, 14, 15, 16, etc. And we are assigning all these numbers to an object or variable called X. Now, if you want to multiply the list of values with 2, how do I do that? Because if you say X multiplied by 2, it is going to provide a dual list. So this line provides dual list. What are you doing in this dual list? You're taking X, which is 10, 21, 3, 14, etc. And then when you say multiplied by 2, you're trying to repeat them again. You're trying to repeat them. And NumPy array will help access the values as well. So you can also say NumPy dot array of numbers of X. X has all these values. You're storing them in Y. Okay. And now this Y becomes a NumPy array. If you say print type of Y, it says that this is of class NumPy dot n-dimensional array. If you were to type here of X, and if I were to run this, it says this is just a list. When you use a list and when you multiply it with 2, it will take all these values and it is going to repeat the values. The values get repeated. However, if you say NumPy dot array of numbers of X, if you're taking this list and if you're converting it to a NumPy array, and then when you say print, obviously, it would say that the type of this is a NumPy array. Now look at what happens. If you say print y multiplied by 2, y contains all the values of X, which are converted into a NumPy array. Now, rather than print out the same elements twice, it is going to multiply each value with 2. So 10 multiplied by 2 is 20. 21 multiplied by 2 is 42. 3 multiplied by 2 is 6. 14 multiplied by 2 is 28. 15 multiplied by 2 is 30. 16 multiplied by 2 is 32. Then if you say y greater than 10, you are trying to look at this condition on what are the values of y which are greater than 10. Here y contains values of X only. Just that we converted the values of X into a NumPy array. Now, if you look at y, is y greater than 10? So is this, because here what we are doing is we are taking all the values of X which happen to be 10, 21, 3, 14, 15, and 16, all these values of X. You are assigning it to y. So now the y variable contains all these values. And when you multiply each value with 2, for example, 10 multiplied by 2 is 20. Sorry, my bad. That multiplication part is done. So I'll just put arrows so that it's clear. Now, when you say y greater than 10, y contains all these values now. Is 10 greater than 10? No, false. Next. Is 21 greater than 10? Yes, true. Is 3 greater than 10? False. Is 14 greater than 10? True. Is 15 greater than 10? True. Is 16 greater than 10? True. And then you want the index numbers. Y of this. Okay, within this you have false, true, true in that way. And then you're looking at index. Y of 0 would refer to the first element. And it is showing us false. Okay. Y greater than 10, false. So what is the number associated with false? 10. It won't be printed, false. Then y greater than 10, true. Wherever you find true, take only those index values. This is 2, index number 3, 4, and 5, right? So y of 0 is false, so that number won't get printed. Y of 1 is true. 2 is 21, so that number gets printed. Y of 2 is false, so it will not get printed. Y of 3 is true, and y of 3 would be this number, because these are in. So this gets printed, 14. Then y greater than 10 for this fourth index number. So y of 4 will be 15. That gets printed. And y of 5 is 16. That also gets printed. That's how it works. So the moment you convert a list into an array, you can do certain operations, right? For example, just multiplying y with 2, and then you get 20 and 42 and 6 and things of that kind, whereas that wasn't possible when we let the variable remain as a list in these lines of code. Okay, and next. If you say From NumPy, let us import a module called as random. And then here you're creating a variable called x. You're saying random dot random integers. You want to randomly choose an integer in the range of 3 to 9. Let me see whether this works so that I show you the different values here. If I say rand integer of 3,9, what does it do? Let's see. It throws an error, sure, for sure. When you say, yeah, so it is throwing an error. So let's not get into that experiment at all, rather. So here, from 3 to 9, you want to randomly choose a value. Okay, so you're randomly generating integers in between 3 and 9. And from that, you're randomly taking a value, putting it here, and you're saying print the values of the same. If I were to run it again, it says 8. If I were to run it again, it gives me 4. Run it again, it gives me some other number. So randomly, it chooses a number. And how is it used? Where is it used? When you want to randomly generate some numbers. And then if you want to practice certain things, like maybe calculating mean or median, or if you want to do any math calculations, maybe you can try out. Okay, next. NumPy arrays share the memory instead of allocating separate memories. For example, say you're importing NumPy as NP. Again, you need not use the same line, import NumPy as NP always, time and again. We need not do that. And here, NumPy dot a range of numbers. And you're storing these numbers in an object called A. And then you're saying print A. If I were to run it, you get to see the values, a range of values. That is 0, 1, 2, 3, all the way until 9. When you say print of A, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. And then you're taking B. Here you're saying A. And when you have colon, colon, and 2, you're saying take all the rows, take all the columns, and then print every second element. Okay. Or I'll probably, that's a wrong explanation probably. This explains the start. This explains the end. And then 2 means for every second index number. And then you are assigning those values to B. You have a start, you have an end, and every second position. So first you start off with 0, then the second index number is 2, then the second index number from there is 2, then the second index number from there is 6, then the second index number from there is 8. So those values get printed. Now you're asking a question using NumPy. You're asking a question on, do A and B share the memory? Are they going to share the memory? If yes, say true. If not, say false. And you get to see true. True means A and B share the memory. They're sharing the memory. And when you say, hey, show me what are the values of A, you get to see that that is an array because you're using NumPy. When you want a range of numbers, it's going to give array of values, 0, 1, 2, 3, so on and so forth. And when you say B, that will also print out the values and say that, hey, that is also an array and it contains 0, 2, 4, 6, 8 in that way. Okay, next. When you say, of course, again, you need not import. I'm not going to explain again and again. If you don't want this, you can remove it. Simply put, okay? So here we are saying numpy dot array. You are creating two lists within that. 1, 2, 3, 4, 5 is one list. 6, 7, 8, 9, 10 is another list. And you are assigning it to ARR. Okay. When you just print ARR, let me run it. You get to see ARR. So you take these values, okay? That is what is there in the print to print these values. Next, when you say print ARR 0, 1, 0 means it will go to this list 0. This is called as list 1. 0, 1. Okay, this has index number 0. This has index number 1. Okay. When you say 0, 1, go to first this, and within that, choose the index number 1, which is 2. And that is exactly what gets printed. Okay. Next, when you say ARR of 0, 2, it will go to list 0, and it will pick the index number 2. Index number 0, index number 1, index number 2 is 3. So this gets printed when you run this line of code. Next, let's pick some value from list 1 and see how it works. When I say 1, 2, what does it pick and what does it print? So this is list 0, this is list 1. So it will go to list 1 and index number 2, index 0, index 1, index 2. So this 8 gets printed. That's how it works. Let's discuss about a few more operations of slicing the elements. Okay. Now, if you create an array of numbers from 1 until 7, and if you're assigning to this, when you say ARR of 1, 4, these are the index number 0, 1, 2, 3, 4, 5, and 6. So you want from 1 to 2, 1, 2, and 3, right? You don't, it won't take, Python doesn't take the last index number, which we have discussed time and again. So this last index number would not be considered. And you're saying print the values. So printing 2, 3, and 4 values out. Then you're once again creating an array of all these numbers. And you're saying 1, 6, 2. What does it do? Let's understand. From index number 1 until index number 5. So 1, 5 means start and end. Okay. Start is 1, end is 6. But Python doesn't, consider the last element. So it will be 1, 2, 3, 4, and 5. 6 is not considered. And you want to look at increments of 2. So first 2, then 4, then 6. If you look at the index numbers 0, 1, 2, 3, 4, 5, and 6. All right. So the last index number is not considered. So you're considering only index numbers from 1 until 5. In this, you're looking at every other element. So first 2 gets printed. Then you skip 1 and take the second. and then you skip one and take the second. That's how you print. You can also print it in this way. You can say 2:6 and then print it. So what it does is index number 2 onwards would be considered. Index number 0, 1, 2. So it will take from here. Index number 3, index number 4, 5, and 6, right? So 5 is not considered. It takes only, 6 is not considered. It takes only until 5. Index number 2 is 3. Then you skip 2 elements or skip 1 element and take the next one. So 5 gets printed. And then if you skip this, there's nothing. So it stops. These are the kind of operations that you can perform on array, NumPy, using NumPy. And then you can also mask the arrays. How do you do that? Using some operations, some math operations. Say here, you're going to print a range of numbers and you're saying 10. And you're assigning it to A. When you say print of A, you get to see the values from 0 until 9. 0, 1, 2, 3, all the way until 9. The last value obviously is not considered. Because indexing starts from 0, the last value is ignored. And when you say print of A, obviously it is going to print all these numbers onto the screen. Then when you say, let me take each value of A and let me find the remainder by dividing by 2. So this will try to find the remainder. And you're equating it to 0. I mean, if the remainder is equal to 0, you're comparing. This is a comparison operator. If you compare this with 0, and if the remainder is 0, you want to store it in this. And then you're saying, go to this A, which has bunch of all these numbers, and print the index numbers of this mask. Wherever you get remainder 0, print only those. So when you get to here, 0 divided by 2 is going to give you remainder as 0. 2 zeros are 0, and then remainder is 0. So A of that mask will get printed. Okay. I can also show you by printing on what would be contained in this mask, in this variable or object called mask. It will give you Boolean results, true and false. We are dividing the first value with 2 and checking whether remainder is 0. If the remainder is 0, it's true. Yes, remainder will be 0. If you take the second element 1 and divide it by 2, remainder is not 0. So false. If you take the next value, which is 2, and then when you divide it by 2, if the remainder is 0, then 2. Yes, so that value gets printed, 2 gets printed. Next, 3. 3 divided by 2, remainder is 1. So 2 divided by, 3 divided by 2, sorry, my bad. 3 divided by 2 would give you remainder as 1. Okay, so that means false. It's not matching, this comparison is not matching, so it's false. So that 3 won't get printed. Next, 4. If you say 4 divided by 2, 2 2's 4, and then you get remainder as 0. So true. True. Comparison. 0 equal to 0 compare. If you compare it with 0, it's true. So that 4 will get printed. This is how the process would continue. Let's do for one more or two more numbers. Next is 5. 5 divided by 2 2 2 is 4, and you get 1 as a remainder. So 1 equal to 0 false. If it's false, it won't get printed. Let's take the next value, 6. 6 divided by 2, you get 0, 2, 3, 6. So is 0 equal to 0? Is a comparison true? Yes. If it's true, that value gets printed here. This is how it will continue for all the remaining numbers, all the remaining values. Then if you say, let me take A contains all these values. When we print A, it contains all these values. Let me find the remainder for each and every value if it is divided by 2. So divide 0 by 2, remainder is 0. 1 by 2 is 1, remainder is 1. 2 divided by 2, remainder will be 0. 3 divided by 2, remainder is 1, so on and so forth. Then we have NumPy matrices. NumPy.matrix 1, 2, semicolon 3, 4. You store it in A and then you say print A. You get 1, 2, 3, 4. You are treating these two as two different values and 3, 4 as different values. So that's how it gets printed. Either because you're telling that I want a matrix, it's putting these in matrix form. Or you do this. NumPy.matrix 1, 2, 3, 4. And you're storing it in B. When you say print of B, it is giving you the values. 1, 2, 3, 4. That's how the values are getting printed. Now we have NumPy broadcasting. This helps when working on different sized arrays. Let's see, we'll understand more. So here using NumPy, we are trying to print a range of numbers starting from 0, and it should end at 40 in the increments or steps of 10. And then you're going to store the values in A. And then you're saying print A. This print A would give you the numbers. Starting from 0, increase it by 10, you get 10. Increase it by another 10, you get 20. Increase it by another 10, you get 30. And the last number is ignored, right? In Python. So 40 would not be considered. You print the values. Then you're creating another NumPy. This time you're creating an array, 0, 1, 2, that's it. You don't want to print any range of numbers, etc. But you're saying you just want the array of values. Then when you say print of B, you get the values 0, 1, and 2. When you say A.shape, you're looking at A and you're looking at the shape of that. And it's saying that when you do A.shape, it has 4 elements. 4, that's it. 4 elements. And when you just type A, it will say that, okay, this is an array which contains all these 4 elements. Then B.shape is going to this B, 0, 1, 2, and it's giving the shape of values. Then when you just say B, it will give you these values, 0, 1, 2, 0, 1, 2. It's an array of those values. Okay, if I go to run it, you get to see the result. Next. If you want to add a new dimension, a new axis, Now here it is probably single dimension. It's saying 4. That means this is an array which contains 4 elements. Here you are saying A of rows, comma, columns. You're saying take all the rows, I mean, all the values rather, and then add a new dimension. Yes, storing in this. When you say a.shape, it will say that, hey, you wanted me to add a new axis. You wanted me to add a new axis, so I do that, 4, 1. Okay, next. When you say print of A contains these 4 elements, right? Now since you change the shape or the dimension as 4, 1, what it is doing is when you say print of A, it will take all these values. It is going to say, okay, you want 4 rows and 1 column. That is how you want to arrange the data. So 0, 10, 20, 30, 4 rows and 1 column. Then you print stars. All the stars get printed. Then you're saying print B. Okay, and then B contains a single element, right? So the dimension remains the same, three elements, that's it. So it gets printed 0, 1, 2. Now again, you're printing all these stars just to show the segregation in the output, right? There is otherwise no big deal there. And then when we say A plus B, you're adding 2 numbers. So you're adding 2 different dimensions. This has 4, 1, that's a dimension shape, whereas the shape of B is only 3. Now when you add, what happens? Let's see. So you are going to take 0 and you're going to add 0 to all these numbers. 0 plus 0 is 0. 0 plus 10 is 10. 0 plus 20 is 20. 0 plus 30 is 30. Then you have 1 here. 1 plus 0 is 1. 1 plus 10 is 11. 1 plus 20 is 21. 1 plus 30 would give you 31. Then you take 2, add 2 to all these values. 2 plus 0 is 2. 2 plus 10 is 12. 2 plus 20 is 22. 2 plus 30 is 32, so on and so forth. Okay, this is how it works. You might want to run that and see the results. Why? I don't like this. I think I need to run this. Okay, now if I were to run it, probably thinking, yep. Now let's get into data structures, which is extremely important when it comes to dealing with data. When you want to deal with data, one should be very well versed with all these data structure concepts. First thing is an array. We have already spoke about this in detail. You can also say from array import star. Star means import all the methods which you might want to reuse. So array is created in Python by importing array module to the Python program. Here you are saying that there is an array and you're saying I, comma, all these values. And you're storing in this. Then you're saying for X in array 1, print X. So what will it do? For X in array of 1, array, or let me do one more thing. Let me say print array 1. Okay. It's just printing the same thing anyways. It's printing I, comma, all these values. When you say print X in this, it will go to this array 1, which contains this, and it will go to this 10, it will print that. Again, it will go to the for loop for x in array, go here, it will print that. Again, for loop for x in array, it will go to this, print that. Again, it will go here, print that. Again, it will go there, and then it's going to print that. Then when you say help of array, it will show you what are the various possibilities within an array and what are the different methods which are available in an array. You can remove something, you can pop out something, so on and so forth. Okay. So all these things, it's up to you on how you might want to explore that. Next. We will try to see something called as insert. And let us see what it does when we say insert. From array, we are trying to import star. Star means import all the methods. And then you're creating an array, I, comma, bunch of all these numbers. Just storing it in array 1. When you say insert 1, 16, what does it do? Okay. It inserts the data at the specified location. Now, when we say for x in array 1, print all those values. Now you will understand where that 60 gets printed. This has index number 0, 1, 2, 3, 4. What are you saying? Insert the 60 at index number 1. Rest all will be moved aside. You're inserting, you're not appending, right? You're just inserting. So in index number 0, index number 1, 60 gets inserted. Then you have delete operation. You're again creating an array of all these numbers. When you say array.remove of 40, it's going to remove that. After doing that, if you say for x in array 1, print the values. You would come to know whether 40 is removed, deleted or not. There we go, 40 got deleted. You have 10, 20, 30 and 50. 40 got deleted. Then we have update operation. From array star, when you say go to the array, I, all these numbers, store it in array 1. When you say array 1 of 2, and you're saying I want to update it with 80, then what happens? This has index number 0, 1, 2, 3, and 4. So you're saying go to this index number 2 and update this with 80. So this 30 gets replaced with 80. There we go. When you try to print that, those are the values that you see. Then we have 2D arrays, 2-dimensional arrays. Now we will understand accessing the values in a 2-dimensional array. The data elements in 2-dimensional arrays can be accessed using 2 indices. Like this, 2 indices, I'll let you know. One index refers to the main or parent array, and another index refers to the position of the data element in the inner array. Next, if you mention only one index, then the entire inner array is printed. Now we will understand all of these things in very detailed manner. When you say from array, print star, it is going to take all the modules, all the methods which are available, and they will be made available for you to use them. And here, you're creating multiple lists. Here we have a list of 4 elements. list of 3 elements, list of 4, list of 4, and then you're assigning it to a variable or object called t. When you say t of 0, it refers to this. T of 1, T of 2, and then T of 3. And T of 0, when you say print T of 0, it will print all these values. And then when you say print T of 1, comma 2, 1 means it will refer to this because 0, 1, 2, 3. Within this, the second index that you are giving here would refer to the element within that. So if you say you have 0, you have 1, and you have 2, so it would refer to this 2. And then you'll get 10. Then how do we insert values in two-dimensional array? You have two-dimensional array. This is 0, 1, 2, 3. And when you say print of t, you get to see all of these. So let me just run this and show you what happens. There we go. So all these get printed as is. When you now say t.insert, what do you want to insert? At index position 2, I want to insert these bunch of values. And then show me t. Rather, I would say, let's see if, I mean, it should not change anything, but let me say I want to print the t and then see whether it's going to arrange in this way. Yet. Print has arranged this in a good fashion for us to look at it. Now, when you say print of t here, it says index number 0 as is, index number 1 would be printed as is, but you're saying in index number 0, print these numbers. So index number 2, then you have index number 3, then you have index number 4. Index 0, 1, 2, 3, 4. That's how the index values are printed. Then here again, if you want, you can once again run this from array import star. Star means all the modules within that you want to import. And then you're creating T, which has bunch of elements in index number 0, index number 1, index number 2, and index number 3. And then if you say print of T, it will show the values for you. Okay, when you say print of T, all those get printed. When you say T of 2, you're referring to index number 2. In that index number, I mean, you're not saying insert in the second position. Here you're saying index number 2, put these two. So what will happen is in index number 2, this is index number 0, index number 1, index number 2. In place of this, you want 11 and 9 to come out. When you say T of 0, 3, you're referring to index number 0, which is these elements. And you're saying, let me go to index number, index number 3 within that. So this is index number 0, index number 1, index number 2, and index number 3. So that index number 3 has to be changed to 7. So this 2 gets replaced with 7. Now when you say T, it shows you that the second index value got replaced and the third index number of the 0 gets replaced with 7. Then let me run this. So from array import star, star is all the modules you want to import. Then you're creating T with all these indexes and values. Then when you say print of T, you get all those values 0, 1, 2, 3. If you say delete T of 3, it would delete the index number 3, index number 0, index number 1, index number 2, and then you have index number 3. So you'd be deleting this index number 3. After deleting that, if you say T, it shows you all the values. So index number 0, 1, 2, and 3. 3 gets deleted completely. Okay. Then we have matrix. Matrix is a very special case of two-dimensional array, where each data element is of strictly same size. So every matrix is also a two-dimensional array. Matrix can be an array, but array cannot be a matrix. Matrix is nothing but two-dimensional array. But you cannot say that if I have array, I'm going to convert that into a matrix. I mean, I'll call it as a matrix. You cannot do that. Vice versa is not valid. Matrices are very important data structures for many mathematical and scientific calculations. Right? Anyways, here is an example. When you say from NumPy, import star, it imports all the various modules within that. Then you're creating an array of different elements. Okay. Here you're giving a string, MO and Monday as in, comma, all these values, comma, Tuesday, all these values, Wednesday, and all these numbers, Thursday, Friday, Saturday, and Sunday. So you're just creating all the values. I always say that, after a comma, you need to have a space, but maybe that would mean too many spaces would be there. That's the reason why probably it's not given. I don't intend to do this, but then I simply can't take the bad practice. Okay, so, or I would say not so good practice. So this is a good practice of ensuring that there's a space after the comma so that when people look at that, it doesn't look clumsy. Okay, that's the whole idea and whole intention behind quickly giving the spaces like that. That's okay, even if that means we are spending some 20-30 seconds doing this. Always a space makes a lot of sense. Okay, now when you use this and when you say print A, what do you think will happen? Okay, this print A would print all the values. And then you're saying, let me reshape this A into 7 by 5. If you reshape it into 7 by 5, you're saying, I want to arrange all these in 7 rows and 5 columns. Okay, so I think if I don't run this, it would make more sense. So it'll be easier for you all to see that. What's happening here? You're just reshaping this A into 7 rows and 5 columns. And then you're printing the results onto the screen. I can make it slightly even interesting here, just to remove these and say A gets printed in this manner, array of all these values. The moment you use this reshape into 7 by 5 and then print it, this is how it appears. Okay, this is one basic function that you can use. Here also, I would do this. I would rather copy this and save it to M. And when you say print M of 2, what will it print? So it prints the second index number. So this is index number 0. This is index number 1. This is index number 2. So when you say print, you get to see the index, all the values of this. Then when you say print M of 4, 3, this is index number 3. This is index number 4. From this index number 4, you have index number 0, 1, 2, and 3. So this 23 gets printed. Next again, just paste this. When you want to add data, did something change? I don't know. I didn't see that. Anyways, again, just giving a space, simple space will ensure that, you know, it becomes very easy, very simple for us to view and make sense out of the data. Always, always, friends, after comma, if you give a space, it looks much better. So we are adding a value by using append to the end. So here, if you have 0, 0 means row. So let's see what it does. When you say append this M, okay, and add these elements at row number 0, would it print that? Let's see. So what are you doing here? Append will append at the end, and 0 means it will add as a row. So it's taking this, and when you say 0, it's appending this, and then it's appending at the end. And then you print star. Then here you're saying insert. If you are going to add by using insert, you're saying insert all these values. 1 means to the column. I mean, it is a column. 1 means you want to add it as a column. So you're saying take this M, then in the 5th position, that is, since you're saying 1, it'll be a column. 5th column, 0, 1, 2, 3, 4, 5. So you're going to the 5th column and you're adding all these 1, 2, 3, 4, 5, 6. That's how it goes. Then we have something called as delete. Again, from NumPy, import star means all the methods which are available, just import is what we are saying. Then all these, you know, it's better that I ensure that all those spaces are there. Okay. And then when you say print M, it is going to print this original matrix. And then when you say print star, you just want to segregate the next output that appears on the output console with star. Then you're saying delete in this M to index number 2, which is a row, and then print N1. Next, what are we doing? We are saying delete from this M index number 2, but this time it has to be a column. 1 means column, 2 means row. Let's print the results out and then let's see what this has to do. So you have M, which is all these Monday, 18, 20, 22, 17, then Tuesday, 11, 18, 21, 18. In that we have everything. When you say print M, it will print the results. When you say print stars, the stars. Then you're saying here delete from this M the second row because 0. So the second row gets deleted, and then you're saying print N1. Then when you say print star, you get that. Then here you say delete from this second column. Column means 1 means column, right? Second column 0, 1, 2. That means the second column, entire column gets deleted. And then remaining columns are printed out. Oh, there are a lot of other operations. Yeah, we'll do that. That's okay. Here we are saying import NumPy as NP, and then you're saying I want to create Z such that I want a diagonal matrix. 1 plus, if you say NumPy plus a range of values 4, what would this do? NumPy a range of values. Let me show you that. So it's taking 0, 1, 2, and 3. And then 1 plus 0 would be 1. You want to print them as a diagonal matrix, and then you're storing it in Z. When you print this is what you get. When you print this, this is what you get. And when you say what is the type of that, it's a NumPy array. Then you're adding 1 to that 0, you get 1. Since you want a diagonal matrix, that's how it is. Along the diagonal, the values get printed. So 1 plus 1 will give you 2. Then 1 plus 2 will give you 3. Then 1 plus 3 will give you 4. You have all those. Then here you're saying NumPy.zeros. That means you want to print all zeros. 0 index number 1, 2, 3, 4, 5, 6, 7, 8, 9, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 0 until 9, there are 10 zeros. And you're saying that Z of 4, that is a 4th index number, you want to have 1. So you're replacing that 0 with 1. And then you're printing out the results to see the results on the screen. Then we are creating a random vector of size 30, and we want to say find the mean value of that. So saying randomly, you want to generate random 30 numbers and store it in Z. If you want to print Z, you get to see all those values. Let me print Z, and then you get to see all those values. So you have all the 30 randomly generated numbers. Randomly, it will generate from 0 to 1. Randomly from 0 to 1, it will generate how many numbers? 30 numbers. You count 1, 2, 3, 4, 5, 6. In that way, you'll have 30 numbers. And then you're saying Z or Z dot mean. That means you want to calculate the mean of all these numbers. You want to store it in M. And when you say print of M, it will give you the mean of all these numbers. All right. And you have one additional thing. After this, we are going to, I'll run this, and then after this, we'll stop. So what we are trying to do is we are trying to print a range of numbers, 50 numbers. You're storing it in Z. And you're saying that I want to choose the start and end, all the values, starting from the last index number. -1 means it will start from the last index number. And you know that 50 means until 50, 0, 1, 2, 3, until 49. So 50 would not be included. And when you say -1, all these values will get printed in the reverse order. You see that? 49, 48, 47, so on and so forth. All these are getting printed in the reverse order. Thank you all so much, friends, for watching this. Please subscribe to our YouTube channel. And on LinkedIn, we are continuously posting the questions. We request you all to interact and then comment, right? Answer the questions in comments. You can just type your answers. And then please follow our page as well. Notify to as many people as possible, and please request them to view the stuff. And we are going to once again connect on Monday. So Friday, Saturday, and Sunday, you can watch all the other videos. You can, get familiarized if you missed out any sections. And then when we connect on Monday, we will take this discussion further, right? Thank you all so much, and hope you all are enjoying it. See you on Monday. Thank you.